Alright guys, so this is the second video that we went over last week, or the material we went over last week, and so most of this should be calculator based. So I want to go ahead and go through some of these questions. Now, SOHCAHTOA, guys, this is not on your formula sheet, so just remember SOHCAHTOA, and remember that you can only use these when you have a right triangle. So here I see, I know this is blurry, but this is a right angle. This is 90 degrees. Over here, this is 90 degrees. Okay, so I can use SOHCAHTOA. And here they're asking me to find this side over here. So since I know I'm going to use SOHCAHTOA, we'll label our triangle. This is theta. So this one is the opposite. Over here, this is the hypotenuse. It's the biggest side, so it's across the 90. And this is going to be the adjacent. Okay, so this is going to be, I want to know the opposite. I know the hypotenuse, so I want to use sine. So sine theta equals over h. So sine of 44.8 degrees equals x over 8. And I won't solve for this one, guys, but remember, you just need to use nsolve for this. Okay, so y'all did pretty good on this when we went over it, so I won't plug in for these answers. Okay, so we're gonna do the same here. So again, oops, I should have done this. What's it? So across from the 90 degrees, so this is the hypotenuse, this is the opposite, this is the adjacent. So I know the opposite, I want to know the adjacent, so I'm going to use tangent. Okay, and again here, guys, I would just use nsolve and get my problem, get the answer. Just remember, guys, this degrees, so don't forget to put the degree sign in the calculator. Okay, I don't know what mode your calculators will be in, so just do that, please. Okay. So law of sine, law of cosine. Again, these equations are given to you. So they are on your formula sheet. They're right there. Okay. So you need to remember that law of cosines. Oops, moved it too much. This one I use when I have side angle side or side side side. Okay. Law of sines is what I use if I don't have this situation. So here, if I look at these, I have side angle side. So I'm going to use law of cosines. So we're going to label the triangle. This is little b, this is little a, this is little c. And here they're telling me to find side AC, which is this side right here, which is little b. So my equation is going to look like this. Again, I'm just taking it from the formula sheet. Okay, so let me type this in. So you should get a big number here. So here it was 440.9, which is clearly a lot bigger than the other numbers, but remember this is b squared, so I'm going to take the square root, and I end up with 20.99 feet. Okay, so I mean, if you rounded to 21, that's okay. So next problem here. Again, I do have side angle side, so I could use law of cosines. So what I'm going to do here instead, though, is I'm going to pretend that this right here is 21 degrees. Okay, so I'm changing the problem. And I don't know this side. Okay, so I'm going to pretend that I'm looking for this side, AC. So I'm not finding BC, I want to find AC. So now I don't have side angle side. So now what I'm going to do is, again, let's label a triangle. This is going to be little b. This one's going to be little c. Little a. So I am going to use law of sine. So sine A over A equals sine B over B equals sine C over C. So since I'm looking for little b, this is the one I want. And the other one I want is going to be the one that has both the angle and the angle and the side. So here I know that I have side C, and I can find this angle right here because I have 21 plus 90.2. So angle, I'm going to use angle C because angle C is equal to 180 minus 21 minus 90.2. So 68.8 degrees. That's what angle C is, this one right here. So I don't even need the information for A. So I just plug things in. So it's going to be sine of angle B, which is 21, over x, that's what I'm solving for, equals sine of angle C, which is 68.8, over 15. And I just use nsolve here. Okay, so I'm not going to type this one in, but I set it up and you guys could figure out how to do the rest from here, okay? So arc length, guys, again, when I talked about this in class, please just be careful what they're asking for. So here they are asking for the arc length. So this equation is not on your formula sheet, so it's just circumference, which is 2 pi r. But since we're not dealing with the whole circle, it's just times theta. So this would be 2 times pi here times r of 8, 30 over 360, okay, which equals 4.19. Okay, if it did ask for area though, remember that is a different equation. So it'd be pi r squared times theta, so this would be pi times 8 squared times 30 over 360. Which equals 16.8. Okay, and again, I should put units here. This is going to be inches squared, and this is going to be inches. Okay, so arc length here, guys, this is just real simple. It's just 25 r times theta, which is 25 times 1.5, which would equal 37.5. So again, not given on your equation sheet, but should be an easy question. Okay, so last questions here, guys. Find the fourth term in this binomial. So again, guys, here, since my degree is 5, I'm going to have 6 terms. So 1, 2, 3, 4, 5, and 6 terms. And you all did really well on this one. We went over it. So this is when I have the A's and the B's. Moving a bit. And now I'm going to do this power. So 5, 4, 3, 2, 1, 0, and 0, 1, 2, 3, 4, and 5. Remember, these can go away. Since I have a plus here in between, these are going to be pluses. And these numbers, the coefficients, I would get from the Pascal's triangle, which everybody, pretty much every period, was able to tell me that these were them. Okay, so since I'm looking for the fourth term, I'm looking for this one. So we're going to take this over here, 10a squared b cubed, which now I'm going to replace it. Remember, this first part is a, this one's b. So it's 10 times 3x squared 4y cubed. So 10 times, distribute the square, so it's going to be 9x squared. Distribute the cube, so 4 cubed is 64. And here I just multiply numbers. 10 times 9 times 64, which equals 5,760 x squared y cubed. Okay, so last slide here. This is not necessarily geometry. This is arithmetic and geo. Okay. So here, all I'm doing is setting up equations, guys, and in the other video, you will see how we use these equations. So right now, all I want to do is set them up. So you do have two. You have a recursive, one for the arithmetic and one for the geometric. And you also have an explicit, again, one for the arithmetic, one for the geometric. Okay. Oops, it blurred out a little bit. Okay, there we go. So the recursive rule, guys, this one is the one that we used a little bit more often. I'm sorry, this is the one we used first. It is easier, so it's just for the arithmetic, it's going to be an minus 1 plus d, and this one's an times r, oh, excuse me, an minus 1 times r. The explicit, which is the one that we're going to be using a little bit more, is an equals a1 plus d n minus 1. And this one here is a1 r to the n minus 1 power. Okay, so we're going to finish this off over here. This is, I can see my pattern is times 3, so that makes this geometric. So my recursive equation is an minus 1 times r, which is 3. My explicit equation is a1, which is 2, times r, 3, n minus 1. And over here, my recursive, so this is adding 3 on each one. So this is arithmetic. So my recursive equation for arithmetic here is, recursive is an minus 1 plus 3, which is d, and the explicit is a1, which is 3, plus d, which is also 3, n minus 1. And remember, we have to distribute to simplify it, so it's, and here these cancel, so this is just 3n. Okay. So again, guys, just look out for the other videos.